All right, let's look at the homework 18, problem number 4. All right, so we want to evaluate this triple integral. All right, so instead, let's turn it into a double integral using divergence theorem. So we're gonna turn it into a double integral over the surface of this solid, which is turned out to be a unit cube. All right, and then we have a v and dot the outer normal vector n and the d sigma. All right, let's draw a picture of the unit cube in the first octant. So you have so you're gonna have let's see, y-axis, and here's the x-axis, and here's the z-axis. All right, then you have 1 here, and 1 here, and 1 there. All right, then we have a cube which looks like this. And here, and here, and here, here, and here. All right, so we have a cube looks like that. All right, then let's look at I'm gonna just name these surfaces. Let's see, I'm gonna call this guy, let's see, S1. So this is S1. All right, and maybe call it this guy S2, and the top one is S3, and maybe on the back it's S4, and here this is S5, and bottom one is S6. All right, hopefully this is clear. All right, so we can just turn this into, all right, so we're gonna just split into, so double integral over S1, right, and v dot n d sigma plus, all right, a double integral over S2 v dot n d sigma plus double integral over S3 v dot n d sigma, right, then plus, and double integral over S4 v dot n d sigma plus double integral over S5 v dot n d sigma plus double integral over S6 v dot n d sigma. All right, so let's I'm gonna do maybe a couple side, and then so let's do S1. All right, so S1 has the outer normal vector, so points that way, which is just the I vector. All right, so this is going to be, so we know that this is going to be I vector. All right, then v, right, so on this side, all right, x is going to be 1. So you can see that if you plug in 1 here, 1 cubed minus 1 squared, so it's going to be 0. So the component here is 0, right? Then here is x is 1, so you're going to have something else. So I'm going to do y cubed minus 2y squared plus y, right? I really don't care. And the last term component is z squared minus 1. Sorry, it's too small. All right, the reason why I don't care about the second and the third component is that you're taking a dot product with I, which only have 1 comma 0 comma 0. So only thing that matters is this guy, but the 0 comma 1 is actually 0, right? So this guy is actually turns out to be 0. right? And S2 is the normal vector here is going to be vector J. So this guy is vector J, right? But vector J on this surface here, y is always equal to 1. And since the vector J so only cares about the second component because J is 0, 1, 0. But the second component, if you plug in y equals 1, 1 cubed minus 2 times 1 squared plus 1 is actually 0. So again, this integral is going to be 0, right? And so on. So you can do one by one. These are fairly easy to compute, so I'll let you finish up for other surfaces, and whatever you get, that's going to be the answer. All right, so I'm going to just say all right, that's it. I hope that this was clear.